So given that f of x is ln of secant x plus tangent x, we're asked to find the second derivative of x. So along those lines, first thing we're going to do is find the first derivative. So we're doing a natural log. This is a chain rule. So it's 1 over whatever we're taking the natural log of, secant x plus tangent x in this case, times the derivative of the inside. Derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. So those are some of our derivative rules. Now, we may want to see if we can do some simplifying before we go ahead and just straight up take the second derivative, because sometimes, especially with these trig functions, because of identities, these things may simplify quite a bit. So one thing I like to do is turn these all into sines and cosines and see if I can get this thing to simplify a little bit. You may remember doing this in your trig class when you're proving trig identities. It's basically what I'm doing. So secant is 1 over cosine x, and tangent is sine x over cosine x, so those can be combined. And over here, I've got 1 over cosine x times sine x over cosine x plus secant squared, is going to be 1 over cosine squared x. So we already see that we are going to be able to combine these fractions. So outside the parentheses, I have 1 over 1 plus sine x all over cosine x. And inside the parentheses, I have sine x. This will be sine x over cosine squared, so I can combine those two. Sine x plus 1 over cosine squared x. All right. Now, this is going to be really nice, what's going to happen next, because notice that this is 1 divided by a fraction, or we can think of this as 1 over 1 divided by this fraction. Well, when we divide by a fraction, we flip it and multiply. So this part out front is actually just cosine of x over 1 plus sine of x. And this is getting multiplied by sine of x plus 1 over cosine squared of x. So we can cancel out one of these cosines in the denominator with this cosine, and these factors cancel out completely. This f prime of x simplifies all the way down to 1 over cosine of x, or secant of x. Now we just have to find the derivative of secant of x, which was part of what we did in the original problem. So f double prime of x equals the derivative of secant x, which is secant x tangent x, and we are done. One of the nice things we've done as well is we've shown that the function natural log of the quantity secant x plus tangent x is its derivative is secant x. So we know that the antiderivative, which if you haven't gotten antiderivatives yet, that's okay, you will. The antiderivative of secant x is ln of secant x plus tangent x.